Hello children, welcome to my channel. So in our previous class, we have discussed about carbon, the covalent bonding in carbon, and also its wide range of applications that it has in our day-to-day life and the products that we use. Most of the daily activities that we do involves the use of carbon. So you can see how important carbon is in our daily life and also how wide range of applications it has. It's a very versatile element. We have also discussed the structure of methane, which is the simplest carbon compound. And in today's class, we will discuss the versatile nature of carbon. So what does this word versatile mean? So versatile means it has a wide number of applications. It's very adaptive, it's adaptable, it has a wide range of uses, it has so many compounds, it's very versatile. So that is the meaning of being versatile. So myself, human beings also are made out of carbon. So you can see how much wide application this carbon has. It's a wide range of uses. There are almost 3 million compounds, carbon compounds that are known to chemists as of date. So 3 million, can you imagine such a huge number, such a big number of compounds that are formed from carbon. So all the other elements put together that form compounds, even the margin is so big, such a great margin, even the other elements put together and form compounds, the margin of only carbon compounds is so great. So that is the reason carbon is called a versatile element. So let us study in today's class more about carbon. Carbon has this unique property of bonding with other carbon atoms, and they bond in such a way that they can form compounds ranging from small compounds to medium sized and very big carbon compounds. So they have this such a versatile nature, from forming small compounds to very big structures and big compounds. So this is just a rough understanding. They form structures from small structures, compounds to very large molecules. So carbon they bond together, they form compounds, and they bond in such a way that they form long chain structures, or they could be branched chain in the form something like this, branch chain, or in a form of a ring structure. So they have these unique properties either in the form of a chain, long branched chain structures, big structures, and also ring shaped structures. So they also form bonding, like we have discussed about covalent bonding in our previous class, and also about single and double bonds. So carbon, they either form single bonds, double bonds, or even triple bonds. Silicon, another element, does form structures with hydrogen, they bond with hydrogen, but the maximum that they would have a structure would be of either 7 to 8 atoms. And this is not stable, it's very reactive, unlike carbon. Carbon bonds, the bonding between carbon bonds is very strong, that they form this wide range of compounds, wide number of compounds that we are known to. So they are stable because the bonding is strong, unlike other elements. Now it is known to us that carbon has a valency of 4. So I repeat, what does this mean, valency 4? It means that it has 4 electrons in its outermost shell. Now I won't get into detail because I have explained this in my previous class. So the valency of carbon is 4. And so carbon can bond to other carbon atoms to form covalent bonding, and also with atoms of other elements like hydrogen, which is a monovalent. Its valency is 1. So that's how they form these structures. And the reason carbon forms strong bonding is because of its size. So just let's have an idea. Drawing the atomic structure. Atomic number of carbon is 6. Okay, this is the valency. So valency, I told you, 4 electrons are required to complete its outermost shell. Here there are 4 electrons. 4 electrons are required to complete its outermost shell, completely stable, completely full. That's how the number 4 comes. So it is so small, and that's the reason the nucleus can hold on to the electrons. They can hold on to the bonding, the covalent bonding. But whereas in large size structures, it becomes very difficult. Like for this is a large size atom, it becomes very difficult for this nucleus to hold on to the covalent bonding, to hold on to that bonding. It's very difficult. That's the reason carbon is having a small sized atom, and that's why they form strong bonding and they are stable compounds. That is the reason, because it is stable, it has so many compounds that are formed in nature. So you can see this, the distance is more as in comparison with a small sized structure. Carbon forms its bonding with many other elements, and they form compounds like nitrogen, hydrogen. So many compounds are formed by linking with hydrogen, which we have studied. Sulfur, just to name a few, chlorine and oxygen. So they bond with so many elements in nature to form compounds. So with the help of some examples, let us understand how the bonding is formed. So methane we have already studied in the previous class. So today we'll discuss this example of ethane. Ethane, its chemical formula is C2H6. So we'll do this in stepwise to draw its chemical structure. So step 1 is count the number of carbon atoms. There are 2. So 1, 2. Step 2. Step 2 is, so there's less space, I'll just draw it somewhere in the corner here. So step 2 is link the carbon atoms with single bonds. And third step, not to complicate things, we'll do it systematically, step by step, for you all to understand, and also when you all do it personally. So step 3 is count the number of hydrogen atoms. It is 6. So we'll start with the extreme ends. So here it's very simple because it's a small compound, but when there are big structures, you may get a little confused. So the extreme ends are not linked to any other compounds. So they would be linked to only hydrogen atoms, and that's why, not to complicate things, this procedure you all follow. So 6, 1, 2, 3, 4, 5, 6. So step 1 is count the number of carbon atoms and draw it. 2. Second step is link it with a single bond. And third step is count the number of hydrogen atoms, which are 6. Start with the ends 1, 2, 3, 4, 5, 6. So again cross check 2 carbon atoms, 6 hydrogen atoms. Now check the valency. The valency of carbon is 4. So it will bond to 4 other atoms. So 1, 2, 3, 4. Right? Same thing, carbon atom 1, 2, 3, 4. So that is how it's done. It is so simple. Valency of carbon is 4. So it bonds with 4 other atoms. It links with 4 other atoms. Here also 4 other atoms. So now with another example, we'll understand about propane. Another carbon compound, propane. Propane chemical formula is C3H8. So this is very basic and very simple to understand. You'll just have to reason out. You don't need to memorize many things. So first step, we'll start. Count the number of carbon atoms in propane, 3. So 1, 2, 3. So my first step is done. Step 1. Step 2. Link the carbon atoms with single bond. Okay. Step 3. Start filling the structure with the hydrogen atoms. So it's 8. Start with the extreme ends. 1, 2, 3, 4, 5, 6. So it's 8. 2 more that we need to attach. Okay. And then check for the valency, whether the valency is completely full. So carbon valency 4, it has 4 electrons in the outermost shell. It can bond with 4 more other electrons, bonding 4, 1, 2, 3, 4. Second carbon atom 1, 2, 3, 4. Third carbon atom 1, 2, 3, 4. So it's full, valency is 4, it's completely done. So by this easy steps, it becomes so simple to understand. You just need to use your basic logic. We'll understand another example, which is ethene. I repeat, it's ethene, not ethane. In my previous example, it was ethane. So the chemical formula is start with our step. In ethane, the chemical formula is C2H6, but in ethene it is E is here. Remember, don't get confused. It's C2H4. So we'll start with the first step. Carbon atoms, link it with a single bond. Step 2. Step 3, start filling the hydrogen atoms. So 1, 2, 3, 4. So the step 3 would be to count the valency. So carbon valency is 4, whereas it has bonded only with 3 atoms here, one more remaining. So it will bond with carbon. So that's how count 1, 2, 3, 4. 4 bonding, 1, 2, 3, 4. So the valency is done. Remember, don't get confused. This is ethene, it's not ethane. Chemical formula C2H4, whereas in ethane it forms single bonding, not double bonding, and that hydrogen would be H6. Another example is ethine with the chemical formula C2H2. So same procedure, stepwise. 2 carbon atoms and then link it with a single bond. Step 3 is count the number of hydrogen atoms. So that's 2, 1, 2. Step 4 is count the valency. The valency is 4, but the bonding over here is bonding with only 2. Carbon is bonding only with 2 atoms. So it will form a bonding. Okay, a triple bond. So 1, 2, 3, 4. Valency done. 1, 2, 3, 4. It's done. So in 4-step procedure, such a simple method for you all to do and understand. So we'll draw the electron dot structure for these for you all to understand the bonding. So for ethene, it's so carbon, so double bonding, structure of ethene, so it bonds with hydrogen. I've already explained in my previous class about the electron dot structure. By now you all should have a thorough understanding about it. So you can see the bonding between carbon and carbon. It's a double bonding. And remember, when there is double bonding and triple bonding, the compound is unsaturated. And when there is a single bonding, it is saturated. So we'll understand the electron dot structure of ethine. So carbon, so by drawing all these structures, when you just look at it, it looks so complicated. You may not understand it. It seems to be very tough, but you just need to use your basic logic and understand it. Not to memorize, just basic understanding makes things very simple to understand. So that's the electron dot structure of ethine. So you can see how simple it is. So children, remember when there is triple bond, when there is double bond structure, carbon compounds, they are called unsaturated compounds. And when it is having a single bond like propane, then it is called a saturated carbon compound. So children, what does this word saturated mean? So it's not only in chemistry that you study saturated compounds and unsaturated compounds, but just understand the meaning of saturated. So in English also we use this word saturated in many sentences. Like for an example, because of the demise of her very close friend, her eyes were saturated with tears. So remember, saturated means completely full. Like in a sugar solution, you keep adding sugar into it, and there will be a level that it reaches that you cannot add any more solute into that solution. So that is called a saturated solution. So saturated, another example I can give is it rained so heavily. The rainfall was so heavy that the soil was saturated with water, which means it cannot take it any more. It cannot take it any further. So saturated means completely full. So that is the actual meaning of saturated. And the same thing applies in chemistry also with our compounds. Saturated meaning means completely full, completely done. So all the carbon atoms are completely full. 1, 2, 3, 4, 1, 2, 3, 4. They are completely full. It is saturated. She reached a level of saturation. The soil was saturated with water because of the rainfall. The sugar solution is saturated. It cannot dissolve any more solute. So that is the meaning of saturated. Whereas unsaturated is, it is not completely full. So that is the reason, because it is lacking another bonding, another atom to bond with, it has to share its electron with another atom. So that's how, which I explained, that's how triple bonding is formed, double bonding is formed, because it's not bonding with all 4 atoms, because the valency of carbon is 4. It's not bonding with all 4 atoms, and that's why it shares a bonding and it forms a double and triple bond, which is nothing but unsaturated. So children, just understand the meaning of the word, and understanding this then becomes very easy. So saturated and unsaturated carbon compounds. So by this we have got a thorough understanding of carbon compounds, how versatile carbon compounds are. And the reason it is versatile, because it is very stable. Carbon atoms are stable because of its size, and they are not reactive. Because they are not reactive, they are stable, and that's how in nature they can form so many compounds which are known to chemists so far, which are 3 million. So carbon atom, let me repeat. So let me just summarize. Carbon atom has a valency of 4, and that's how they form their bonding, because of its 4 valency. When one is not full, when the valency is not completely full, then it has to share the electrons, where they form double and triple bonding, which are called as unsaturated carbon compounds. When it's completely full, when it's saturated, when all the valency is full, then it is saturated carbon compounds. Carbon atoms, because of its size, because it is small, and that's why the nucleus can hold on to those bonding, those electrons, whereas in large atoms the bonding is very weak, and because of its strong bonding it forms stable compounds, it forms a wide range of compounds in nature. So this is so simple to understand, and we'll conclude today's class. I'll see you all in my next class, and if you all have any queries or any doubts regarding my explanation, then do drop your comments down below in the comment section, and I will try to reply to you all at the earliest. So I'll see you all in my next class. Stay updated.